The C5515EZ DSP USB stick has two push button switches. They are connected to a port called GPAN1, and here is the circuit describing how these switch push buttons are connected. And they are not connected to a GPIO, but they are connected to a successive approximation analog to digital converter. So this is a kind of ADC that uses a series of comparisons to determine each bit of the converted result. You can read more about the successive approximation ADC, and there is the successive approximation registers in the C5515. So the device includes a 10-bit successive approximation register ADC using the switched capacitor architecture that converts an analog input signal to a digital value at the maximum rate of the 62.5 kilosamples per second for use by the DSP. And the way we're going to detect is when you read, we have different voltage levels depending on which switches are closed. So if switch 1 is closed, we have approximately 1.5 volts. If switch 2 is closed, we have approximately 0.9 volts, and if both are closed, we have approximately 0.72 volts. So with these combinations, we can detect if the switch 1 is pressed, if switch 2 is pressed, or if both of the switches are pressed. So before we start reading push buttons values, it's important to talk about push buttons debounce. So the mechanical characteristic of push buttons makes this problem, this kind of noise, that when two contacts of the switch hit together, they tend to bounce off of each other a few times before settling down. So most mechanical switches has this bounce problem. There are many ways to deal with this problem, and we can also use some software debouncing techniques to minimize this problem. To read the push buttons from the C5515 board, we are going to use this function here. It's in this file. So basically we have some values for switch 1, switch 2, and both switches and no key. So we define that this is based on these voltage levels I explained before, and then we will have a counter. The timeout is 10 milliseconds, so that we will give 10 milliseconds for this debouncing, and we will read values, and we will put these values in a buffer, and we will compare the values between buffers, and if the values don't change, we can say that the value is stable, and we can use this value. So here we have these buffers. We have here we check the value of switch 1 with some tolerance, and if the value is in between this interval, the value is equal to switch 1, so we know that switch 1 was pressed. Otherwise, when we read the values from this ADC and it's in between this interval, so it means that it's switch 2 is pressed, and here this interval means that both switches are pressed, and this is when no switches are pressed. And we are comparing also here with this buffer, and we update with the debounced new input in case that the last three values are identical. And if not, the switches they changed, but they were not debounced, and we'll wait for this debounce time, 10 milliseconds to pass, and then we will read again. So this is how we will return, for example, 3 states. So if no key is pressed, we will return 0. If switch 1 is pressed, we will return 1. If switch 2 is pressed, we will return 2. And if both switches are pressed, we will return 3. So this is how we're going to read our push buttons. So I'm here back in the Code Composer Studio. We're inside this file, and I'm looking at this function I've just described. So we have here at the SAR header, we have the definitions for the values of switch 1, switch 2, switch 1, 2, no key. So their values will be compared with these defined values here, and then we will define which switch were pressed. We also have this timeout for debouncing, which is also defined here, and it's related to the sampling frequency. So If we change the sampling frequency somewhere in our project, we need to make sure that everything is synchronized and we are using the same values. So the rest of the function goes as I just explained. We compare if the value is inside some intervals, accounting for some tolerance, and we also account for the bouncing, and then we will return a value. So it's from 0 to 3. 0 is no key, 1 is switch 1, 2 is switch 2, and 3 is switch 1 and 2. So with this we can read from the push button and we will know which switch were pressed.